Hey, is Radari set up on this?
Uh, it should be like there might be like the Windows version of Radari, like under disassemblers. Yeah, it's there.
That could maybe be something to look at
hmm
sometime, or even tonight if you have time.
Okay. Yeah, I don't know how different it is as like a GUI on Windows. Most of what I've done with it has just been like command line on
I think
Linux.
Cutter is isn't Cutter the GUI one?
Oh yeah, I think it is. Okay,
So it might be the same. I don't know.
cool. Okay, yeah. So maybe depending on how much time we have left for today's meeting, maybe we can go over that, or we'll save it for the next one.
Because I don't think any of the people in here have learned Radari. I know
Okay.
you're big into that.
Yeah, it's a fun alternative, especially just because it's free, compared to like IDA. But I guess we also have Ghidra now, which is a pretty strong competitor. Cool. So I guess we'll just start today's club meeting, which is the first one for the spring semester. Oh, hey, we just got a. Oh, hey, Joey, how's it going?
Hey, what's up? My bad. I thought it was an hour from now.
No, sorry. Yeah, we rescheduled, or I guess your hour.
Yeah, I'm in Colorado, so I'm an hour ahead or whatever. I spaced
Yep.
it out.
No, you're fine. Easy mistake. We can give you a minute to get your VM ready, but I'll just fill you in real quick. So the goal for today's club meeting is we're going to be going over just sort of like a brief introduction to X64 Dbg or X64 Debug. And it's just sort of like a newer version of like WinDebug, although I can't remember which version we used for our last meeting, but there's actually a newer version of WinDebug from Microsoft called WinDebug Preview, which I would show, but I was experimenting with mine and I broke it. So I'm trying to figure out how to uninstall it so I can demo that. We might do it another time, but once you're familiar with one debugger, the concepts and generally like the icons and what you're doing it's the exact same.
Right, yeah, it seems to be that way.
Mm-hmm. Cool. So you guys can all see my screen, right?
Yep, I can.
Cool. So you'll be able to get the resources for today's meeting if you go to the drive. And if you don't know the link, I will put that in the chat real quick. And that is drive.malware. That's MALWR .club. Oh, yeah, let me make that a hyperlink actually. Yeah, there you go. And it'll be under the examples folder. And you want to download license_1.c, and then if it'll let you download the executable as well. And then I didn't time myself going over this before, so it might be lengthier than what we can cover today, but we can also pick it up another time.
My VM is saying I don't have internet and I can't finish the setup unless I have internet.
Oh, sure. So you're going to want to open up, if you have it, don't know if you can see my screen, but on the bottom left, there should be like a blue square icon.
I can't even get to the desktop. It's like in the
Oh,
like setup phase still.
oh, I wonder if it was, must have done an update.
Oh, wait,
So
there
it's-
we go. Now it's on the desktop, but I don't have that blue icon on the toolbar.
if you just go into the browser and type captive.apple.com, that might work.
I wasn't even registering that it was like had a valid connection. It just popped up though, so I think I'm good.
Okay, so you can connect to things now, or?
I think so. It's being slow.
Okay. Yeah, just let us know when you have this stuff downloaded from the drive.
Which one was it again?
It should be under examples folder. And then you're going to download the license1.c and the executable.
Okay.
Unless you want to try and compile it differently, but that might cause problems.
It's not downloading. You can get started. I'll just mess with it, and if not, I'll just watch.
Okay.
What about Odin? Are you getting yours to download?
Yeah, mine downloaded. Yeah, it's all set.
Okay. Cool.
Mine aren't really downloading either. That's why I was wondering if it was a. Maybe I'll just try another browser. I'm trying an Internet Explorer. Maybe I'll try Chrome.
Yeah, I did it on Chrome.
You can start without me. That's fine.
Okay. it might need to change the file hosting for this.
Might just be Internet Explorer because that's what I was doing too.
Oh, true. Cool. So this program that we're just using to sort of demo and get a better understanding of just x64 if you haven't used it before, you're just not that familiar with using debuggers in general. Yeah, it's just a sort of mock tutorial reverse engineering program that I got from a YouTuber. You can look up his channel. It's Live Overflow. And he has other sort of challenges like this, or just examples if you want to go through them. So you can look up his channel, you can go through that. And he kind of goes through like a different like reverse process for documenting binaries and just understanding like their general flow. But we're just going to be focusing on using this debugger instead for today. So once you have it downloaded, what you're going to do is you're going to want to go to Flare folder on your desktop, and you'll want to go to debuggers here at the top. And then you'll open X32 Debug because this is a 32-bit application. And if you try to open it with X64, it'll close, and it's going to tell you to use X32 instead. So you can click that. I'll just close out mine. There you go. And what you'll do is you can go File and Open. And then you'll navigate to, for you, it's going to be under your downloads. And you should see like license 1 exe. You'll open that. For me, mine is under this folder here. And you'll see it spawns this sort of what looks like a command prompt, but it's just the process for that executable that's running in the background. And it's currently being held at like the entry point breakpoint. And you can see that here. Or no, it's just int3. So just kind of to go over this, if you've probably used other debuggers before, and that's maybe like Ollie debug or WinDebug, and for the most part, again, the fundamentals and just the concepts behind these debuggers is the same. So whatever you learned today, you should be able to also use with those tools as well. Before we get too far into the actual debugging, we'll just kind of go over like the actual configuration for X64 Debug. And that is under Options and Preferences here on the top of the toolbar. And is my screen too small for you guys? Can you see everything, or do I need to like try to bump it up?
Fine to me.
Okay.
Yeah, you're good on my end.
Yeah, I could see it.
Okay, so you'll just look under, again, that's the Options tab here, and then Preferences, and we'll just kind of go over what all these different options mean. So the first one is System Breakpoint right here. And what this does is when you're loading a new process, it will cause X64 Debug to break in the system function, which initializes the application you're attempting to debug. And that's where we just initially loaded into the program. You can see here at like, can I? No, I can't. I'm just gonna do it anyway. So where we're at like right here. And then go Options again. So the next one is Tls Callbacks. So Tls Callback is a function which is called before the main application runs. This can set parameters or even be used by certain protectors, just to implement like anti-debug methods. This is going to allow you to break on those functions. And then you have the entry breakpoint. That causes X64 to break on the entry point of an application. So for general debugging, it's the only breakpoint you'll really need to have checked initially when starting the debug process. Because then as you go through and you try to like document the flow, you're going to be adding your own, like at different functions or individual instructions. So next one you got here is Dll Entry, and that's going to cause it to break on entry point of any DLL, which is loaded by the process. So we'll briefly break away from that again. And I think we should be able to see under memory map. So those DLLs would be like here, like with kernel 32, app help, or another one you'll see is like NT DLL. So whenever these are being loaded in at their entry point, the debugger will break there as well. And this is something that it'll do by default if you ask it to. We don't have it checked, so it's not doing that. Then the next one is attach breakpoint. When this is checked, it will cause the debugger to break in the debug UI remote break-in function when attaching to an active process. If unchecked, it's going to attach without suspending the process. And then we have thread entry, and this will break on the first instruction of any new thread initialized by the current process. Then we also have options DLL load, DLL unload. So of course this will break in the system function when a new library or DLL, like we just showed with like NT DLL or kernel 32, is loaded or unloaded from the active process. The DLL load breakpoint is going to occur before any of its code is executed. And then we have the thread start and thread end options. And this will allow us to break in system when our debugged application initializes or terminates a thread. So the next options are going to be here under the settings for engine. And sort of just the main ones we're going to go over real quick is enable debug privilege, breakpoint type, and the undecorated symbol names. So for the breakpoint types, it's just a feature that's going to...
Hey, Micah.
Yeah.
Could you maybe make your screen resolution smaller so it's easier to see?
Oh, sure. For that... Oh, shoot.
Just like on the desktop inside the VM?
Yeah, I'm not sure if it'll let me because I'm using RDP.
Oh, yeah, I forgot.
Yeah, I kind of do it weird.
What about your main monitor or whatever you're viewing this through? Would that do
Yeah,
it? Or?
that I might be able to. I just got to get rid of this. The zoom has like a little thing at the top that I can't.
Well, may it take over sharing, or you could stop sharing, or?
Oh yeah, that's a good idea.
Sorry to interrupt everybody, but I could hardly see.
No, you're fine. Yeah, I just have to bump up the resolution on my monitor.
Or bump down.
Or yeah, sorry, that's what I mean. Okay, this looks kind of funny.
That's worse.
Yeah.
You might have to go back to whatever you were or something. Sorry.
No, it's fine. I think I can.
Or maybe reopen it.
Yeah, I think it's just one of those things where like, oh, yes.
Sorry.
Oh no, that's fine. See if I have anything important open. Yeah, I think I can just.
Did you make your screen resolution bigger instead of smaller?
No, I made it smaller,
Oh,
but then I don't know. It's just
got it.
applications all have like their own like DPI or like screen zoom settings, and they don't reload until you like log out, log back in, because that setting has to be changed. wonder if maybe here it's just going to take me a second, but I should be able to fix it. It's better that I fix this anyway, just so it shows up better on the recording anyways.
If you put labels on what you do in the video, you might get other random people from the internet watching. One of them has like 125 views.
Yeah, I noticed that. I thought it was kind of funny. Sorry, I'm just trying to get everything reconnected. Sometimes I really like the iLab. Some days I don't.
What's Joey been up to?
It's been pretty hectic over here. Been doing you know, a bunch of moving stuff the last couple days, which is why I almost missed the time for, you know, jumping in here.
Oh, sure.
Graduated too after this last semester, you know, so been enjoying some of the free time I've been getting.
You gotta do masters now.
Yeah, I'm planning on taking this semester off and then probably going to continue in the fall and go for, you know, the Masters of Computer Science.
There you go. Yeah, it's not any better.
What about just web console, even though you hate that?
Oh, yeah. Okay. I can do that.
That way it would let you change your screen resolution. It might fix your problem.
Yeah.
I think Odin's doing his master's in cyber defense, though I think he's considering other possibilities too.
Yeah, I'm considering possibly switching over to computer science and just taking if it more like advanced cyber related classes like as my electives.
Yeah, I'm planning on starting mine this fall as well. Be graduating this semester, so.
Nice.
Were you happy with the cyber defense, Micah?
I did computer science.
Oh, okay.
And then I know they have like a cyber specialization you can do, but I didn't quite like what they had set up, so I just took all of my own electives instead.
Okay.
But it was I liked it. I mean, and plus I thought it was nice because I already have the cyber ops degree, so it made more sense for me just to do like computer science. And if I want, you know, there's always that option to go for something cyber again, you know, for either another master's or for a doctoral.
Do you think that the cyber ops undergrad degree prepared you enough for the code in the computer science one?
So surprisingly, there's not a lot of programming in the master's computer science. It's mostly doing math and theory.
Okay, that's just something I was wondering.
Yeah.
Even with that algorithms class, I feel like that one would be a lot of coding.
I mean, it maybe for other sections. I took it over the summer, and it was supposed to be with Scott Graham, but as some of you know, he passed away recently, and it was taken by Austin O'Brien. So it was mostly like theory questions and like, here's this program, so give me like the big O notation and justify that like with a proof.
I think that's mostly how Graham did it too.
Okay, yeah. So for me, it was mostly math, which isn't something that I know CyberOps really focuses on.
Just had that intro to discrete class.
Yeah, so intro discrete kind of touches on it, but I didn't feel like it was quite enough. So if you do plan on taking it, I would maybe think about how comfortable you are with just your understanding of doing things like sets and just maybe like college algebra.
I've always been pretty good at math. I thought that intro to discrete class was like one of the easiest classes I've ever taken. So.
Oh, okay. Yeah, I've always been just trash.
I got like
I think it was the
110% in
instructor
that
though.
class.
That intro class was real easy, and then I got to regular discrete math, and man, that shit kicked my ass.
Sorry, it's taking a minute to get everything open again. Can you see better?
Oh yeah.
Okay, cool. Oops. Yeah, this is just the source code right here for what we're working with. Cool. Yes, then I guess pick up where we left off. And we were covering, yeah, the engine tab. So cool. Yeah, so just recap. So we're covering the different like configuration settings you can use for X64 or X32 debug. And these are the engine settings. So the first one is the breakpoint types. And it's just a feature that allows you to try the different breakpoints if your program detects or blocks the default int3 breakpoint. Here we just have int3, which probably like in my own experience, like 90% of the time you're just going to use the int3. The other two that are worth going over is enable debug privilege. So this will allow you to attach to system processes, and then also undecorated symbol names. And that just allows you to make symbol names look cleaner. And it's kind of like, I believe it's like a form of demangling. So typically you would get, and this isn't probably the best instance of it, but I can see what I can find real quick. So if we go like right here, typically, so like this call right here, I believe this would be an instance of like name mangling, and it's where the debugger tries to figure out what to label. like a function call or like a offset that's being called. And here you have like license underscore 1 dot this offset 9b10 c0. And this is a bad example because the reason this is mangled is because the debugger doesn't have the MSDN symbol table information. So it would tell it that after analyzing this function call here, that this is actually the printf function. And that's a separate issue, which I tried to fix, but I didn't have enough time to figure it out. But if I do, I'll probably be pushing you guys some new VMs. So I'll go back to the options and preferences, and we'll just keep chugging along. Yeah, so exceptions pane. This will just tell you what which exceptions you would like to ignore and pass to the program. So if you leave this blank, the debugger will break on every exception. And if you want to ignore all exceptions, you would just add like the range, like 1, 2, 3, 4. I have to make sure I count this right. 4, yeah. So the range that to just F, 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 F. It's just every, oops. Well, I typed that wrong, but it should be F, like all Fs or all zeros. And that's just because, you count 0 to F. So 0 being the least and F being the highest. And then if you do add the last button, it'll allow you to add like the most recent exception, which the program you're currently debugging incurred from like the ignored list. Yeah, I don't think we've hit any exceptions. So as you can see, it didn't add anything. I'm not sure we'll have an instance of that we can even demonstrate here. But then under the disassembly pane, we have options like argument spaces. This will put a space after every argument, changing the instructions like move rex rdx to move rex rdx. It essentially puts like a space after every comma. So it's just like a formatting thing. Memory spaces. So this will put a space in between memory reference instructions and their operators. So this would cause like the instruction move EAX byte pointer DS EDX plus 18, and it would put a space in between the EDX plus 18. And then you have the option for like uppercase, hiding different sizes. You might even want to permanently highlight different comments or labelings added from like the PDB or symbol tables. One second. Sorry, had somebody calling my name. So then you have also things like auto comments only on CIP, and this will remove like all comments or including like things like references from the current disassembly, except things at the instruction pointer, and that's the instruction that's being currently loaded at the moment. And then you have other options like GUI, and this is if you just want to change like which parts are loaded in on the GUI, or if you want to save the layout that you have, or if you only want to show certain registers as in little endian. I haven't really messed with this. The only one that I think you might like change for maybe stylistic reasons is if you want to show like the RVA addresses in the graph view instead. but I've never needed that. Otherwise, we also have the miscellaneous pane, and just quickly go over this. The miscellaneous pane will allow you to configure the debugger to be like a just-in-time debugger, so the system can attach to the process whenever an exception or a problem occurs. We won't be going over this either, just because it's not really something you need to do most of the time. Maybe at a later point we could show this as just like a one-off technique you want to do, but it would take a while to explain it and just to set it up so that we could even do it. Otherwise, we can just jump straight into actually using the debugger and trying to maybe get a grasp for the flow of this program that we have here on the right. And just to kind of briefly go over it again, the program we're doing is like a mock license verification program, and we can show it running in the command prompt, or yeah, so yeah, so you can see it just dumps out. If you don't have any arguments, it just says like a help sort of information about how to use the program or the usage. So now we're just going to do like, and there you can see it took in this string as an argument. It went to check the license to see if the key provided was the correct one, and it printed out wrong. So that's just very briefly oops, that's the wrong way. Flow of the program from beginning to end. And if we kind of just match this up over here, looking at the source code, you can sort of see that as well. So you have the int main here with argc, argv. If argc equals 2, print. So that's if you have the program here, license, and then the key argument. So that's 2. Then we're going to print checking license, and we're going to print this argument that was provided. And then if string compare, the string provided is the same as this string, then, and that's equal to 0, because when you call string comp, it's going to return the flag 0, saying it was the same. So if it equals 0, then we're going to print access granted. If it returns back a flag not equal to 0, so equal to, I think it's 1, then that means it was not the same, and it's going to print out wrong, like we just saw here. Otherwise, if the, that's weird. I think that should be like that. Yeah. Otherwise, if there were more than 2 or less than 2 arguments, anything other than 2 arguments, it's going to print out the usage sentence there, and then it'll return 0 and close. So that's the program. Just looking at the source code, which is pretty easy to do. But what we're going to do is we're going to use the debugger, and we're just going to try to briefly go through that too. But we'll also cover the different buttons you use, like under the debug pane, what all of these mean, and then we're also going to probably touch on a couple of these. So with it we'll jump back to main at the entry point Cool. Yeah, so this is where the program's currently loaded in at the moment. And we know that because you have EIP pointing right here at this instruction. And before we run it, we'll just go over what these all mean. And you're going to be using these buttons probably the most out of everything, because these are how you navigate the program as a debugging process. So the first one at the top, run, or you can either click this, or you can do F9. That's the shortcut. This starts or resumes the process normally if you have it paused, or yeah, I guess you would only have it paused. And then you have run until selection, and this will run until you have either like some kind of instruction you're looking for, or maybe like a reference to a string, or a call to a function, or just it could be like a reference to some offset in memory. You have pause, and that's just going to stop the program at that instruction where it is currently. And you have restart, so this would like reload the program, so it's effectively the same as like saying, have you tried turning it off and back on again? So that's what it's going to do. It's going to close it and then reopen it with whatever arguments or initializations you've provided. Then you have close, and this will close, it'll exit the process. You have step into, and this allows us to enter into a routine or into maybe an instruction and execute that next step. So you could just keep clicking it and it'll keep going. You have step over. Oh, and sorry, I guess I haven't been mentioning these, but I mean, you can kind of see them. Step over, which is F8. And this allows us to execute an entire subroutine and repeat that instruction without stepping through it, instruction by instruction. So I am actually going to go back to where we just were, because this will be easier to explain. So like if you were here, let's say the EIP was pointing at this instruction, and you were to hit step over, it would run through every instruction in this call. And then when it finally gets to the return instruction, it'll bring you back here. And then that's where the EIP will be pointing. And then you have the execute till return. This will resume the process until a return instruction is executed. So if I remember correctly, I mean, it's kind of like the same. It's not exactly the same as doing a step over, but let's say you were in this call to this function, it would, and you were to like be here at the top, and you're like, oh, well, you know, I don't really care about seeing what happens here. It would execute until it hits like a return. So I believe that would actually go here. And then once it gets through all this, it would stop at that return there. And my back button doesn't work. I'll just go back there. Cool. So yeah, so then you have until user code. I've never used that one. Have you used that function before, Brisney?
I haven't even noticed it until now. I'm wondering, is that just going to like anything that's non-library, non-system code? If so, that's a pretty cool feature.
Yeah, I think you're right. Let me
I'm just guessing. I don't know.
So I clicked it, and it went to in entry breakpoint. Maybe I should click it again. Okay.
Is that part of your?
No, because it shouldn't. The actual user code isn't until here. So from this push EBP down to this pop.
Maybe it includes other things the compiler adds.
Yeah.
I don't know.
Huh. Yeah, it's interesting. I'd have to look that one up and get back to you guys. I didn't have that included in my notes. Otherwise, I mean,
maybe if you're in like kernel 32 or something, that might get you back to the image executable. Maybe.
Oh, true.
I don't know.
You know what, here, let me look it up real quick, just because I mean that is interesting. So I don't want to spend too much time just having you guys stare at my screen, but I'm just looking up on my laptop that I have right next to me.
While you're looking that up, I'll just speak briefly. He has the advanced one selected, and you can see there's many different options there.
Oh yeah, so
those.
I have those ones in my notes, but I skipped over them just because
they are a little advanced.
Yeah, yeah, and I mean, for the most part, they're not too different from what we just went over, except for maybe like pass exceptions, swallow exception.
Those could be useful.
Yeah. But I mean, they're functionally the same as like the step intos and the execute till return, but they're just where it gets more complicated is how they handle those exceptions and what they do with them. This one's kind of neat though, skip next instruction. So, you know, if you have the EIP like right here, you could just keep running and, you know, skip each instruction. And sometimes you might do this if you want to like manipulate the result of a register before it gets to like a comparison. But that's kind of a situational thing and depends on what you're actually trying to do with the debugger. Like if you're trying to trick it into doing a comparison and then throwing out a flag because the result you have stored in that register at the time before the comparison like fits that case. Like if it were comparing a value stored in EAX and the value is, let's say, like 1, and it's comparing it to, you know, like here, the value 2, and you want to see if they're not equal or if it's less than, you know, it's kind of, it's a puzzle. Yeah, and then the next one we would want to go over is breakpoints. And for that, I don't think, so I just used just like right click in the pane, but I didn't believe there's a actual, no, there isn't. Okay, yeah. So typically like when you're gonna click on something like here, I have a breakpoint already established, but you would go here and you could set a conditional breakpoint. You could toggle it and it would just be like an execution breakpoint. Then you have two others. The three main types of breakpoints you're gonna use are like execution, so the one I just mentioned. You have memory breakpoints, and you have hardware breakpoints. An execution breakpoint is the most common and most used type. So when you toggle a breakpoint on a specific address, it'll tell the debugger to stop when that address is reached in the execution. And to use this, you simply press F2. So you can see that right here. Or
you can also just touch it.
Yeah, or you can just do that too. And then the other options you have are the memory breakpoint. So a memory breakpoint is used when you want to pause an application, when a specific area of memory is either accessed, written to, or executed. Here it says conditional, but it's the same thing. this is handy like when you want to determine if a specific area of memory is used by the program. And then also if this is available, again, just clicking here, but you can do Shift F2 and that'll do it. Oh yeah, also, so I mean, what you could do, so you can do these set conditionals, and this is kind of a tangent, but to see if something is being accessed or not. Because if you set that condition, you say, oh, well, this like region of memory or this function looks interesting, but I don't have the time to go looking for it, even though, I mean, it'd probably take you like a minute or two, but you could set that condition to break if it's ever accessed. And it might be useful, like if you're fuzzing a process that you've attached to the debugger, and you want to be able to catch it like when it crashes. That might be a reason you do it. Otherwise, typically, I mean, you might also just use like follow and dump or follow and memory map, because that'll also show you like how that's being accessed. Otherwise, the last breakpoint we have is a hardware breakpoint. And a hardware breakpoint, this is used to pause an application when a particular address is either written to, if it's read, or executed. Specifically used to determine when a particular variable is set. It can be used for byte, word, and dword reads and writes. And I believe the only way you can enable this type of breakpoint is directly through here by doing the right-click breakpoint and set hardware on execution. There's no shortcut.
And you know why you'd want to use the hardware instead of the execution breakpoint?
No, actually, I've never had a reason to use it, but I've never gotten to those instances.
Some malware has the ability to, so if you do just the F2 one, that's going to insert a breakpoint into the process image, and some malware can go in there and search for those and remove them. It cannot search for the hardware breakpoints, so it cannot remove those, but the catch is there's only 4 of them. So if you think it's doing that or you suspect it's doing it, the other one's not working, then you might try the hardware.
Okay. Yeah, so it's surprising how much functionality is kind of built into these things. They really do try to like take into account everything. Cool. Yeah. So I guess the next thing we do is we'll just start the program, and we'll try to get to the main function. And for that, I'm actually just going to restart it because I'm not sure if I messed with anything. If you are actually working with malware, though, you want to be careful with how you're using your breakpoints and when you're hitting run. Because if you have a breakpoint set that's never going to be hit, and the malware gets to some function or spawns other processes that cause it to deploy or detonate, that's bad. So it's usually a good idea to have snapshots taken as well, just in case. And then sometimes it's also good measure just to have like your network disabled. But right now, this isn't a piece of malware, so you don't have to worry about that, and it's good to practice with examples like this one. So yeah, so this is initially like an entry breakpoint, I think, but we want to get to our main function, and to do that, you can actually just look here in the memory map, and you look for here for the info. You have a process here, license _1.exe. Typically, the offset to get to like the main function is just gonna be like 1,000, and you can see that here under the .text executable code. You have the entry point at 9B000, 0 hex, and then at that plus the offset 1000 hex, you can go here, and boom, you can see here there's a reference to this offset, and this shows what's contained there, and it's checking license %s/n, and you can look at our source code over here, and it's 100% matchup. So that's how you know you're in the right location. There are other ways you can do this, like if you want, and this is again kind of a tangent, but you can go into a decompiler, or no, wrong one, disassembler. And typically, most people are probably going to use like IDA, but there's Radar, Ghidra, you have Cutter, which is a GUI for Radar, and Binary Ninja. I'm going to back out real quick because the one I want to use is the demo version of IDA, which for some reason is missing right there. But I have it right there. Cool. So, okay, we're going to open a new, you don't have to follow along for this. I'm just kind of just showing it. Once you have the program loaded, it's going to show the call graph, and I'll zoom out a little on it so you can see the whole thing. And this is also like another method you can use because sometimes it can be a little harder to visualize everything within the debugger, especially when you're looking at it in just sort of a long form sort of disassembly like this. If you can get a little more background information if you look at it through like a disassembler like IDA. Here, IDA already found this function for us, which is really handy. But you can see that the base or the entry point is at like 40 0 0 0 0 hex, and then at this offset 1000 hex, you have our main function here, and you can use that as another way to know at what offset from the entry point you need to be looking for in your debugger. It's also nicer because, and for some reason this didn't recognize it either, but that function is printf. And now this is a call graph. So you actually have like three main sort of ways you're going to visualize code. You have the source code, you have a call graph, and you have, if I can find the right window, disassembly here. And these are sort of like three main ways you're just going to be like looking at a program.
And also, or
sorry, no, you go.
Could you tell them about the graph view inside of X64?
Oh, so I know it's in here, but I didn't get to it. It's under.
So just put your cursor into the.
Oh.
Go back to view and CPU.
Oops, wrong button.
No, try view CPU. I think that'll change it back up at the top.
Oh, yep.
Just type G.
Oh, yeah, there you go. Yeah, so this is the same thing as well.
Which won't help you find main, but you can still see the graph view. But it's just a picture is all.
Yeah, well, I mean, sometimes it's just a lot nicer though, instead of like looking at the disassembly. And it can, actually, I prefer looking at it like this sometimes. I didn't know, like I'd seen in other places when I was getting all my notes prepared that you could do a graph view, but I've never actually done it before in X64, so that's interesting.
I know everything, of course.
Yeah.
And I think you just go view CPU again to get back, or at least that's the way I do it. I don't know if there's a shortcut.
Oh, yeah, right.
Even though you're in CPU, but if you want to just see the...
Yeah, cool. Yeah, so for...
Or I guess Alt-C would do that.
Oh, is that the...
That's the
Oh,
shortcut.
okay, cool, yeah. So I guess, again, just for everyone, so if you're in the disassembly view, you press G, and you get graph. If you're in the graph view, you do Alt-C, and that takes you back. Or you can do it from here. Oh, okay, I see, and then, yeah, that shows the shortcut. Okay. Cool, so now I just have to remember where I am in my notes. Right, so...
You're talking about main.
Yeah, so I guess we're not actually at our program yet. So if you guys want to, the next thing you would do is go to call stack, or not call stack, I keep getting them confused. Go to the memory map, look for license _1.exe. You're gonna go here on the address on the left side of this pane, and you're gonna hit the 9B1000. And that'll take you here. And then I already have it set, but you're gonna wanna right click it, breakpoint, and toggle, or you can do F2. And then that'll prepare us for that. And then you can actually go back to thread, double click main. This will take us back to where we are in the process at EAP. And you're gonna hit run. And you're probably gonna have to hit it a couple times. And there, now you can see EAP is at our breakpoint 9B1000. So this gets us to the beginning of the program. And we can actually look in graph view again, and you'll see pointers here at the top at push EBP, and we're at the beginning just of this general flow right before the comparison for EBP plus 8, which is probably, sorry, not probably, it is argc, because it's comparing it to 2. If it's not equal, it's going to go to here. If it is equal, then we're going to go over here and just go back to our source code. So if equal to 2, we go here. Not equal, here. And you can see that here now in the graph view. So just to, I did just mention it, but I guess I didn't also explain it. So thread view, this just shows all of the currently active threads for the process. Here we only have one thread for the program, and it's this main thread. So you can always click the main thread, and you should, it'll take you where that, to where like the EAP is. If you click it, that's what we just did, and you can see it there. Other parts you might want to, you'll be interested in is call stack. Sorry if you can hear my cat meowing. I locked her outside of my room. But the call stack window, it just sort of gives us a list of the functions and procedures, or maybe routines, which brought us to our current location. You can use this window to maybe analyze these routines and then learn about the application's execution routine, just the control flow. If you double click any of these, it'll follow its location in the disassembler. You can also just make these a little bigger too. That's better. But you can see here, we're currently at 009B1000, and you can see where it's from and where it's to. So I think if you click here, yeah. Interesting. Yeah, so I guess if you click that, it's just going to take you back to where it's currently, yeah, okay, where it's currently at. Right, okay, yeah, so, and then when the program, okay, yeah, sorry. So looking at the call stack, you have 9B 1000. It's it's called from 9B 12B1 here. And you can click this and it'll show you back in the disassembly. Here you have the address 9B 12B1, which is odd because you have the call above it at this address to 9B 1000, which takes us back to here at our breakpoint. So that's just kind of a brief overview of how you can see the different subroutines or the functions and how they're being called or how they're being referenced. You also have the memory map, which is separate from the call stack and threads, but shows where things are located in memory at their address and then the size of that reservation or allocation. You have like here our main program here, license1.exe, and then you also have like all the different DLLs that have been loaded in. So next, I think we will try to capture the program and look at the registers as it stores like the arguments, the values provided, and then before it makes a call to like string compare. And we'll show how that's handled. See if I can, cool. Yeah, so here on mine, for change command line, you'll see in quotation marks we have the path to the program. And then after that, you have the arguments. I think we can also change this with the init command. Yeah. So you could do, and this is probably going to be different for you guys. It's probably downloads, but oops. Users, malware. Oh, wrong button. I hit enter. There you go. So I'll go over that again because I went through it kind of quick. So this is another way you can also initialize a program. You can do it through here at the bottom, and this is the command line. This is something else we'll have to go over another time, but you can also, there's Python integration for X64 and X32 debug, and you can control that directly from here. But what we're doing here is just a default command built into the debugger. And what this does is it loads in this executable, and then you do a comma and this argument. And then I think you would do like multiple, another comma and arguments like after that, but we only have the one. So you do that. It's also like another way you could restart it, I guess. And you can verify that that changed by going to the change command line up here. And this does effectively the same thing. But then what we got to do is, cool, so just make sure that your breakpoint's still enabled. here. Then we're going to run again. So we're there at that point. And if we step into it, you can watch over here on this pane, and after here at this comparison, you should see a flag change, and then later on again, when we do the string compare, you should see an offset to this argument be loaded in, and then also an offset for the string to be moved into one of the registers. And we can verify that again. If we just look over here at IDA, or I should probably show graph view instead. Oh, that's messy.
I like IDA.
Yeah. So in IDA, and then you have, so we have the checking license, and then you can see, so it's going to be this call right here. Just after push to EDX. So if you look over here, right here, so this call right here is going to be the string compare. So if you want to see at what offset the two strings are being stored in, I believe you have to look at push EDX, and then also this one here. So I mean, we of course we already know like where this offset's at, because I mean it says it right there. It's 9C8018. But then you can also see where it's going if we hop through, and I'll make sure again, just looking at IDA. Right, yeah, so it should be, yeah, okay, yeah. EDX will be the first string, and then string 2, yep, is here. And IDA actually comments that for you if you're using the demo version. I think if you're using like just the free version, you won't get these sort of comments, but it's really useful. The big difference between using demo and then the free version is you can't save anything you do with the demo. It's, you know, to incentivize people to pay for the pro version so you can save your work. But I know a lot of people just use the demo and then the free version, and then they just copy the annotations made on the demo over to their free.
They do also have a new paid version that's a lot cheaper than it used to be. Like it's by subscription for like $400 or so a year.
Oh, that's
still a lot of money though. But
yeah, well, a lot less than the initial. Right, so yeah, the two offsets then that we want is this push EDX, and then this push here, and they'll be used for the string compare. So you'll get those offsets by stepping through it and then looking for those two. So you can just go back here and we can hit F7. And you can watch over here and you should see it all update. I also might have just zoned out. Oops. Yeah. Okay, cool. Yeah, so back program, and then so this right here is for the second string, so for the actual key. And if we go F7 again, you should see it get moved onto the call stack over here. See? Yeah, so it's on the top there. And then as we keep going, you'll see push EDX. So you'll see it gets stored here in EDX at this instruction. And then you'll also see it when we hit the push instruction, it'll pop over here. Yeah, see, so in EDX, you have here at this offset is where the string is stored, and then you'll see it get pushed on, and it's there now on the stack. So when we call here, and we can actually just do debug step over, and now we're at this add, you should see in EAX, yep, so here at EAX, I guess maybe you can call it a flag, the result of string compare is stored there. And 1, if you remember looking back at our source code, means not equal. If it were 0, EX would be 0, and then we would continue on. But we'll actually keep going and you'll see what happens. So we're testing, so we're going to compare EAX against EAX. If they were both the same value, it would equal 0. It's not, so then we do it's not equal, and you can see it just jumped down to here. And if we go back to IDA to look at the call graph, it would have been right here at this test EAX. It was not equal, so we went down to here, and it should print out wrong. Yep, and you can see it's pushing wrong. It's going to call printf. It's going to print that out. And oh, I messed up. You're supposed to do step over, not step into. But we can do execute till return, and then F7 again. And yep, that took us back. And you can make sure again just by comparing the instructions, and there's a reference to usage key, and then oh wait, no, I think I'm looking at the wrong one. Oh yeah, so we haven't got there yet. So it's going to finish its call, and we'll do step into again. Yeah, so it's going to jump now, and it shows the arrow here. It's going to jump down to this XOR EAX, which is it going here after. Yeah, so it goes wrong, then to here where they both use a jump to get to the end of the program, and it cleans the stack up and returns and end of program. And we'll show that just over here. You go step 7, jumped, 7, F7, F7, and now the program's taking off, and it's back here where we showed on the call stack how there is this reference to 9B1000. Or not reference from, but so there's a call to 9B1000 here, and then the return goes to this address where EAP is now pointed to. So that's sort of just demonstrating how to use X64 Debugger and see the flow, and we've seen what it looks like when you take the wrong route, and then we can go real quick down here. See if it's, no, it wouldn't be there. We'll go to the memory map, and I'm just going to grab this. Yeah, I don't know, I was thinking that. Sorry. I'll grab the string right here from our source code, and then we'll just see what it looks like going through the correct flow, and not bypassing, but making all of those checks with the correct string. So you can copy it. We go command, and then you'll go up, and we'll just reuse the same one, but you're just gonna remove the fake string we gave, or the fake, sorry, license key, and you'll add the correct one. You'll do init, and then our breakpoint is still there, so you can hit run, and now we're back where we were, and you can just kind of step through it. So F7, F7, it's going to compare. We have 2, so it will do jump equals, or sorry, not jump equals, but it was equal, so it's not going to do the jump. And then F7, so we keep going through it. Sorry, I just noticed something was wrong. Init did not update, I think. Oh, that's my bad. So I think we're supposed to actually do it up here. Command line. Let me just double check real quick. Oh, okay, yeah. So that's my bad. I don't know why the init command didn't do it, but for sake of brevity, I guess just to get it to run, go file, change command line, and then you're going to paste the license key there, actually, where we had the whatever string you entered. For me, it was ASD dash ASD. You can just click OK. You'll rerun it, hit run a couple times till you get to our breakpoint, and then just F7, and you can watch as everything kind of goes through. Looking at our call graph, you can see we're about right here at EDX. Yep, EDX, and push EDX. So we're about to push the offset to the checking license string. And then we're going to make a call to printf. What you can do is you can just go debug again, step over, step over. So now we've made our print, and I think you should actually be able to see this in the process. Yeah, so this is all being updated again in this window because we have the debugger attached to the process. So as you're running it, of course, it's going to print those statements out in this sort of command window. And you can see that we have the correct license here because it's being printed out. So you go here, and we're just going to F7, keep going through it. You can see the actual license key is on the stack. Now, the new one that we entered is on the stack, and they're going to get string compared. Again, you're just going to do step over, and you'll see here in EAX, the flag is now 0. So that means we succeeded. Both the strings are the same. So now it's going to do test, same value. So they were equal. So we're just going to keep dropping down. It's going to push the offset to access granted. We're going to make a call to print 7. or not, sorry, not print 7, print F, but we're just going to step over. So you do F8. I don't know where did it go. Do we got to do it again? Oh, whoops. Okay. Or no. Weird. Weird. It's not responding. I don't know if anyone else is having this issue right now. Weird. Yeah, this is so weird. Oh, okay. I have no idea why that. I just went into the process window and I just clicked enter and it unfroze. Weird. Yeah, here, let me just restart that and see if I can get it to.
Have you tried patching it?
No, I haven't tried with this one, but I bet that would be interesting.
You want to try?
I'm a little, you might have to walk me through, but I'm a little rough on it at the moment.
Why don't you change it to something that's not correct in the command line, and then go find the comparison where it checks for, or the comp where it's checking for 0 or 1.
Sure. Yeah, so we can go up to File. I think I remember how to do that. So we'll just change the K at the end to like a Z. That should be more than enough. And we'll have to restart it.
But where in IDA does the comparison happen? That would be maybe your first step.
Yeah, I think we could probably just do. I mean,
or you could change the J and Z maybe to JZ.
Mm-hmm. Well, can I also just like modify the string at the offset?
That's harder to do. I think that's less successful.
Okay.
I think it's better just to modify some of the instructions.
And you just
sometimes
check the access granted too.
Mm-hmm.
Yeah, so the J and Z there to the JZ would do what he said there.
Okay. Sure.
Hopefully. Sometimes some people have had real problems with patching in this software, so I don't know. Hopefully it'll work. And binary edit.
Oh, right there.
And then you gotta go to hex and then look up the value.
Oh yeah, sure.
Jack can look it up in a second if you want. Oh no. So they have, what's the instruction? 75. What was the original one?
Oh, shoot.
Just close out of it.
Yeah, 75.
75 0F.
So if we do 74, right?
Let me check here. 75 0F. Oh, that did work.
Let's see if it goes. So
yeah, that 74 should be correct.
okay, so we have 1 in EAX. So it should just keep going down, right? To push and not jump.
So if it's incorrect, then it should just go to the access granted if that was the right one that you did.
Yeah, so I guess
Can you try exporting that?
yeah,
So you should be looking for a patch.
oh, right there. Yep. Gosh, the font's so small.
And then it should be, we already got selected, so I think it's patch file.
Yeah.
And then you got to give it an executable name. Don't erase that because you might not work. Just call it like license 2 or something.
Sure. Yeah. Cool.
We'll see if it works without it, like in the command line or something.
Yeah. Huh. Yeah. And I guess, ta-da, we just did a patch. That's funny.
It's not always that easy though.
No.
Sometimes it is.
I remember.
Sometimes I've had it where you change an instruction and it'll patch it, but then when it saves to the executable, it'll be some weird, bizarre instruction.
Mm-hmm. Yeah, it's always fun doing that. It's like Sudoku, but reverse.
I think if you're wanting to do this kind of stuff, sometimes it's simple is better than more complicated, less room for error.
Mm-hmm. Yeah, I think I've only done, I mean, I guess I haven't done too many CTFs, but the few that I have, there've been a few binary challenges where, you know, you definitely could have patched it and gotten the flag.
Is that allowed?
You know, I'm pretty sure it's not like maybe in the spirit of the competition, but
I don't know the rules, so I was involved in that, so I don't really.
I think
it's a legitimate question.
Yeah, I mean, maybe if it were like a serious enough competition. I mean, I've never done like super like competition ones, but I think so long as you get the flag, they don't usually care. But I mean, that's also probably because I just haven't done like collegiate like competition ones. Otherwise, I think we've been going for almost 2 hours now, like 20 minutes shy. I think that's most of what I have to demonstrate today, unless, I mean, there's a couple other things we could go over, like maybe just following offsets in a dump, or
do we have any questions from the audience or club members?
You know, it was kind of a lot of stuff that we just went over.
What about ideas and thoughts about things people want to see next time? Anybody have any special requests? Or
what was that tool you were talking about at the beginning?
Oh, Radar? Or
the one that Brizendine was talking about?
Yeah. Yeah, I've always called it radar, but I think I've come to learn that I might be pronouncing it wrong.
I've heard radari. I don't really know what the correct way to say it is, so ask somebody who knows. It's not
yeah.
me.
I always confuse the folders. Yeah, so the next one, the one that he had suggested was maybe learning how to do this. I can open it. We could go over this. Oh, it's weird. It's not. Here, let me see if I can find my Ubuntu. I know it should be installed, but oh, and that's not working. There you go. Yeah, so I've always done it from here, and it should be the same. Like, I mean, the commands for the most part, I mean, they should be exactly the same. But I wonder if maybe we'll Cutter open. I've never actually used Cutter, so I've always done it from command line.
I think Cutter is fairly new. What about you, Olden? Are there any particular malware things you're interested in seeing talked about or wanted to learn about or don't care?
None that I can think of at the moment, but I'll keep it in mind.
I don't know if you know anything about it, but like cryptojacking malware would be pretty cool to learn about.
Oh, like stealing like Bitcoin wallets and stuff?
No, like one that would make your computer mine.
Oh, yeah, okay, cool. Yeah, we always ran into this because I did an internship at a bank a few years back in Sioux Falls, and sometimes like it was with their ops department, and sometimes you'd have to like quarantine a computer because somebody was installing extensions for whatever reason, and it would, you know, the extension would do probably what they wanted, but they would also do like Bitcoin mining in the background.
Probably be Monero.
Yeah, yeah, that was one of the most common ones.
Yeah, because that's CPU mine now, so that would be probably the target.
Yeah, if you want, I could probably find a recent deep dive into it, and we could go over it. I'd have to find a sample, but are there any like particular Monero flavors you're interested in?
I don't really know of any specifically, but I don't know, I've always thought about like making a botnet to mine Monero would be kind of cool, but
With like Raspberry Pis?
I'm just like cryptojack it and then just like have them all linked together in a botnet and feed it into an account.
Yeah, I mean, you know, I'll just close this window. We could, yeah, we could go over that. I'd be interested. I think that'd be pretty interesting. And I'll probably have to find someone else's report on it, and then we could just maybe try to follow their steps and go over the analysis together as a group, if that sounds interesting.
Yeah, I think that'd be pretty cool.
Cool. Yeah, because otherwise, I mean, the things that I had planned were just keep going over like tutorial stuff like this using different tools. Cool. I know.
You can always email Josh to see if he knows any samples or has any.
Oh, true.
He might not.
Yeah, I feel like I know he always posts on Twitter. He does like his own analysis of like things he finds in the wild, because I think he has his own like honeypot set up with Cuckoo. So that'd be probably an interesting question. Cool. Otherwise, I don't know, do you have any announcements, Brizendine, or?
None that I can think of.
Okay, cool. Yeah, I don't have anything that I can think of at the moment either. So I guess we could just call that for today's meeting, and then.
Or I guess one other thing is,
oh, sure.
just kind of administrative. If people, I think Odin has agreed to become a vice president. I asked him to become a vice president. If there are other people that want to be officers, there are other officer positions available. I think those can be defined. If other people want to present on anything later in the semester, even a short 10, 20-minute thing, whether they are online and they're not currently with us right now, or they feel free to let Micah know and plan it with him. Otherwise, we'll just continue with Micah, and I think Odin might do 1 or 2 later on in the semester.
Yeah, that'd be great. Yeah, actually, I mean, if any of you have like your own individual projects, or maybe there's a tool that you've been playing with and you'd like to demo it or show it with everyone, I think that'd be great too. It could also be if like you find a report on a specific piece of malware that interests you or something you've seen in the news, we could talk about that. Pretty much open to anything malware and RE related.
Otherwise, Micah's doing a good job, and we'll just continue along with what we've been doing. He enjoys leading and sharing information, so don't feel like you need to do something if you don't want to, but it might be fun to do 1 or 2. You never know.
True. I will be gone after the semester though, so never know. Cool. Yeah, so I guess that does conclude today's meeting though. Our next one is the week after from today's, so that'll be, if I look at my calendar correctly, the 9th? Yeah, the 9th of February. And that should be, if you're ever unsure, check the website. It's on the Google Calendar. I think you can also sync the Google Calendar with yours. I don't know if I need to change anything to make that possible, but
if people really want calendar invites, you can email me. I can set it up so you'll get an invite for each of them.
True.
But
yeah.
I would only do that if you asked me to. So you could just send me an email or say it in chat or something.
Yeah, and I guess I don't know. I feel like most of the people who regularly show up already have a hard time remembering. So, yeah, so that's fine. Okay. Yeah, I guess we'll see everyone again on the 9th.
Cool.
I'll stop recording.